Hello, this is the luckiest maths teacher in the world. Thank you so much for tuning into this video in which we will look at interpreting some different statistical graphs. So before we get to those graphs, we need to know the difference between the two types of data, because which graph we use, which statistical graph we use will depend on which type of data we have. So these are the two types of data. Numerical is when the data is in numbers, and categorical when it's in categories. So think of the data, so data is just the information you collect, as if you were going to ask a question. Would the person respond with a number or a category? So for example, if we take this one here, hours spent on homework. If you ask someone, how many hours a week do you spend on homework? They respond with a number, like 4, 3, whatever. Could even be 3.5, but they would give you a number. So that is an example of numerical data. So we'll put it over there. Similarly, if you were to ask someone their height, how tall they are, they would give you a number. Might say 178 centimeters, 165 centimeters, but they would give you a number. So if you collect information about height, you're collecting numerical data, because if you ask someone their height, they'd respond with a number. So what about eye color? Well, if you ask someone their eye color, they're not going to give you a number. They're not going to say my eye color is 2. Doesn't make sense. What they're going to do is give you a category. So they'll either be in like the blue category, have blue eyes or brown eyes, hazel eyes, whatever. They're giving you the group that they're in rather than a number. If you ask someone their favorite sport, they're not going to give you a number. They're going to give you a group. They could be in the soccer group, the football group, whatever, but they're in a category. So eye color and favorite sport are both examples of categorical data. All right, let's look at some statistical displays. So I'm going to start off with two displays, one here. They look kind of the same, but the differences are subtle. This here is a bar graph or a column graph. Doesn't matter which one you call it. And it's called that because you can see it's got bars and columns. So this one here looks similar, but it's a histogram. The difference here is in this histogram, the bars are touching and the data is numerical. This graph here shows eye color, which I said on the previous slide was categorical data. We're seeing different categories along this horizontal axis. Whereas over here, we have the number of siblings. Well, that's obviously numerical data. If you ask someone how many siblings they have, they respond with a number. So this is a histogram. This is a bar or column graph. Histograms, bars touch, and it displays numerical data. And here, bar or column graph displays categorical data. Each of these is a category. Now, along the vertical axis, you see F here. That just means frequency, how many times things occur. So for this one, you can see the blue bar's drawn up to a frequency of 10. So that means this is like a class of students and 10 people had blue eyes. 7 people had green eyes and 4 people had brown, 4 people had hazel eyes. So we might write those numbers just to make life a little easier for ourselves. So the red number is how many times it occurred. So this same data can be displayed down here in what is called a pie chart. So pie charts also display categorical data. It's displaying the same data in categories. But these two displays are used for different purposes. This is good at showing you how many, the absolute number that are in each category. Pie charts show you the proportion that are in each category. So we can see clearly here that blue is the biggest category, then green and hazel and brown are about the same. So unlike this display here, we can't actually tell how many people have blue, green, hazel, or brown eyes. We're only looking at the proportion. So this type of graph, the pie charts, they're good when you're dealing with things like percentages. Like if I wanted to display visually the percentage of our students born in Australia, South Africa, New Zealand, whatever, a pie chart would be good. It shows you the proportion rather than the total number of things. But both of these display categorical data. So over here with the histogram that displays numerical data, sometimes you'll see this placed in what's known as a frequency table. The frequency table just tells you which score and how many times it occurred. You can also have a frequency table for categorical data, but here and here we're displaying numerical data. So this little weird symbol there means sum. Sum of frequency equals 21. That means that there are 21 scores in total. So this data here and this data here are the same, both displaying the number of siblings. This is just a visual representation. You can tell things about this straight away, like the most common number of siblings here was 2, but this here gives you the information in a different way. Okay, so when you're dealing with categorical data, you can't calculate the mean, median, mode, or range because the data's not numbers. We can only calculate that stuff when we're dealing with numbers. You can't calculate the mean eye color. That doesn't make sense. You can, however, make some observations from this graph. For example, you can see that there are 17, 21, 25 in total. So you can see that 10 out of 25 people, which is 2/5 of all people, have blue eyes. So the fraction of people that have blue eyes is 2/5. And you can see blue is the most common, followed by green and then brown and hazel. So still gives useful information, but we can't calculate mean, median, mode, and range. Over here, we can calculate mean, median, mode, and range because the data is numerical. So you can see here for the number of siblings, clearly the mode is equal to 2. So just so we're clear, this bar corresponds to 0 siblings, 1 sibling, 2 siblings, 3 siblings, 4 siblings, 5 siblings. So the mode, the highest bar is 2. It occurred the most. The range is also really easy to calculate as well. So here the highest number of siblings was actually 5. So the range is highest minus lowest. 5 minus 0, which of course just gives you 5. So let's say I wanted to calculate the median. So here I know the number of scores is 21. The median's the middle score. So the middle score here would be the 11th score because there would be 10 scores below it, scores 1 to 10, and there'd be 10 scores above it, 12 to 21. Remember, whenever you have an odd number of scores, as we do here, there's just one middle score. So the median will be the 11th score. So the 3 lowest scores are 0. The 8 lowest scores are either 0 or 1. So there's 8 people here that have 0 or 1 siblings. So the 9th, 10th, 11th, 12th, 13th, 14th scores are all 2. The 11th score occurs in this bar. So that means that the median would be 2. So the middle score 2, and we said it was the 11th score because there are the same scores above it as below it. Remember, we can't calculate mean, median, mode, or range for this data here because it's categorical and not numbers. All right, thank you so much for tuning into this video. This has been the luckiest maths teacher in the world. Have a great day.